Hello and welcome to Kids Heaven Public School online classes. My dear grade 11 students, with our subject of computer studies, we are discussing about the topic conversion of number systems. So far, we have seen different types of conversion. Now, we are going to see another interesting part, which is a non-decimal fractional number to a decimal number system. Now, here, for example, we have a binary number 101101, but it has a point also, 0.101. Now, how are we going to convert this to a decimal number? That's a little confusing, right? But let's try it out. It won't be that difficult. Watch out. We have this number 100101 in base 2. This is a binary number and we have to convert this to a decimal number which is in base 10. The first thing we do, we write down the digits. As we did earlier, remember we wrote the digits, we wrote the position number and then we wrote the positional value. The same way, we will note down the digits first, then we will take the fractional part. We get the fractional part by putting the exponents at the top of the base. Now, remember one thing more, we are converting a binary number. So we shall use the base of 2. When we are converting an octal number, we will use the base of 8. Okay? Don't get confused. Watch out carefully. Now let's see. This is our binary number. Let's note down these digits. 1, 0, 0, 1, 0, 1. This is the integer part. Now let's take the fractional part. 0.101. Now we have fractional part. Now what do we do in this fractional part? We write the base which we are converting from and then we put the exponent value. Now we have the bases 2, 2, 2. We will use the same base for all because it's all in binary. Now, remember, when we have a number line of numbers, the left side is the positive side. The right side numbers on the number line are in negative. When we begin the counting on the left side, we always begin with a 0. The next will be a 1, 2, 3, 4, 5. If you have 6 digits, the total value will be 5 because we begin with a 0. Now, let's look at the right side. We shall not begin with a 0. We shall begin with a 1. But after the point, this side will be in negative. The exponents here will have negative values. So, it's a -1, a -2 and a -3. These are the fractional parts. We have our point here. We have noted down the exponent values. We can see on this side we have all in positive. Begins with a 0. Don't forget that. After the point, the exponential values are in negative. And we begin with a 1, not a 0. The next thing we do is to begin calculating the decimal value. What do we do in this? We multiply each digit by its value and the next digit multiplied by its value. Let's put it in written. You will get it clear. So, the first one is a 1 multiplied by 2 power of 5. Okay? We are going to add this, the next digit, which is a 0, multiplied by its value. You know, maybe you make a division like this of lines. That will avoid a confusion for you and mistakenly do not pick a wrong value. That's better, right? Okay. Now let's multiply the second one. 2 to power 4 plus the next digit 0 multiplied by 2 to power 3 plus 1 multiplied by 2 to power 2 plus 0 multiplied by 2 to power 1 and plus 1 multiplied by 2 to power 0. This is only the integer part. We have the fractional part remaining. Let's do that too. The first one is a 1 multiplied by 2 power of minus 1. Add it to the next digit 0 and 2 to power minus 2. Okay? Now let's go for the third digit, which is a 1 multiplied by 2 to power of minus 3. Now this is the decimal value here. The next thing we do, we are going to open up these brackets and get the calculations out of it. So, let's take the calculation one by one. 2 to the power of 5. Multiplying 2 5 times. 2 by 2 4, 4 by 2 8, 8 by 2 16, 16 by 2 32. So 2 to power 5 is a 32. Write it 32 plus the next one is a 0. Anything you multiply by 0 is 0. The next one is also a 0. Plus 0 plus 0. Okay? Let's write it down. Doesn't matter even if it's a 0. Then next we have 1. 2 to power 2, which is a 4. And 4 multiplied by 1 is a 4. Next we have 2 to power 1. 2 to power 1, whatever. Okay? That's 2 multiplied by 0, which is a 0. Then we have 2 to power 0. We know any number that has an exponent of 0 is equals to 1. So 2 to power 0, which is 1, multiplied by 1, 1. So 0 and 1 here. Okay? Now this is the integer part. Let's take the answers to the fractional part. Now we have 2 to power minus 1. Now when we have 2 to power minus 1, that is 1 upon 2 to power 1. Okay? When we have a negative exponent power here, we bring 1 upon that. So 2 to power 1, which is 2, 1 upon 2, which is 0.50, which is a half. Next we have 2 to power minus 2, which is 2 to power 2. So 1 upon 4. Okay? And 1 upon 4 gives an answer of 0.125. The third one, which is 2 to power 3, that is 1 upon 2 to power 3. 2 to power 3 is an 8. So 1 upon that is going to be a 0.652. Okay? These are the additions of the integer part and the fractional part. Now we can see we have additions in between them. Let's quickly take the sum. 32 plus 4, 36 plus 1, that is 37. Okay? This is the first part. Now with a point we have this second part. Now when we add these, the addition of the second part is, I think I've done something wrong here in my multiplication. Yeah, just a moment. Sorry. When we have a 0 multiplied by 2 to power 2, it is a 0. 0.652. Now we have to add this and this, which is equals to 37.652 in a base of 10. Okay? Look at it step by step, you will understand it better. The first thing we do, we write down all the digits. Do not forget to put the point. This is very important. After that, we take the exponential power of each of the digits. Always remember on the number line, the first part, the integer part has positive values and it begins with a 0. After the point, we have negative powers and it begins with a 1. The next thing we do, we multiply each of the digits by its fractional part value, add it to the next one and subsequently. We do this for both the integer and the fractional part. After that, we open up the brackets, complete the additions of both of them. In the end, we add the integer and the fractional part. The result we get is the new decimal number that has been deduced. This is converting a binary number in a fractional part to a decimal number. Now, when we are converting this similar thing to an octal, what we do, we use an 8 here. Instead of a 2, we use an 8. Let's add this. This is going to be also interesting. Let's quickly have this 2. So we are now going to convert an octal number 605.12 base 8 to a decimal number. Okay? So let's quickly note down the digits. We have a 6, we have 0, we have 5, and then we have a point, then we have 1 and 2. Now we are converting from an octal number, so the base here is going to be an 8. Okay? Let's put on the values. We're starting from here. This will be a 0, 1, 2. We're going to have negative values on this side, -1, -2. Okay? Now let's deduce the decimal value. Let's begin. The first one, 6 multiplied by 8 to power 2 plus 0 multiplied by 8 to power 1 plus 5 multiplied by 8 to the power of 0. We have our point here. And then the next one, 1 multiplied by 8 to power -1 plus 2 multiplied 8 to power 2. Let's open up the brackets and see. 8 to the power of 2, 8 multiplied by 8, which is 64. Now, 64 multiplied by 6, which is 384. So we have here 384 plus, we have a 0, so this is going to be 0. Next we have 8 to power 0, which is 1, multiplied by 5, which is 5. We have our point, 8 to the power of -1, which is 1 upon 8, which is 0.125. You see, whenever you are converting exponential values with a negative, you have a 1 upon that number during the conversion. Now we have 8 to power 2, which is 1 upon 16, and that will be 0.3125. We have these additions. We have to complete these additions. Let's quickly have them. So the first one we have 384 plus 0 plus 5, which is equals to 389. Isn't it? 389. We have a point, and then we have the second one, 0.125 plus 0.3125, which is equals to 0.15625. And we are to add this. So adding this, we have 389 dot, we have this 15625, the base of 10. Now this is the new number that we have deduced. We are converting an octal number, a decimal number. The octal number has a fractional part. We are first going to write the digits, take the exponent values and multiply each of the digit by its value. After that, we take the sum of both and we add them. The result we get is the new decimal number that has been deduced. This was a non-decimal number with a fractional part converted to a